Good morning. Today's topic is ionization of weak acids and weak bases. So, first consider a weak acid which gets partially ionized as follows. That is HX plus H2O gives H3O plus X minus. Okay. The acid gets, HX is the acid which gets partially ionized as follows. Now, first the initial concentration. Initially only reactants will be there. So, let C be the concentration of this acid, and at that time there will be no products, so 0. Now, next change in concentration. Before that, let alpha be the extent of ionization. Alpha be the extent of ionization, or we can say degree of dissociation. Okay, let alpha be the degree of dissociation. So, change in concentration will be minus C alpha. C alpha decrease in the concentration. That is the decrease in the concentration of ionization of HX, the reactant acid. Okay. Now, what will be in the case of the products? C alpha will be the so the concentration of these products increases whereas the reactant decreases. So minus C alpha decrease, and C alpha will be the concentration of these products. Okay. Now this is a change in concentration. Next is equilibrium concentration. What will be the equilibrium concentration? So equilibrium concentration will be C minus C alpha. Here same C alpha. Okay. Now we know Ka. Ka is the equilibrium constant. So equilibrium constant will be equal to the products C alpha into C alpha. So C alpha square by C minus C alpha. This is the concentration of reactant. Okay. Now this will be equal to C alpha square by 1 minus alpha. Okay. So this will be K. Now, Ka is the ionization constant of the acid HX, and Ka is the measure of the strength of the acid. Then, Ka is also dimensionless. Okay. Greater the value of Ka, stronger will be the acid, and Ka is dimensionless. Now, we know pH is equal to minus log H plus concentration. Okay. So say similarly pKa will be equal to minus log K. Okay. So if Ka is known, we can calculate pKa also. So from this, if Ka and C are known, we can easily calculate alpha. Okay. So next we are discussing the different steps involved to calculate pH. How can we calculate pH? Okay. Calculate pH. Different steps involved. First step, identify the acid. Okay. Identify acid. Then next, we are writing the balanced equation of all possible reactions, right? Balanced equation of all possible reactions. Now, what will be the next step? Reaction with higher Ka is identified. Okay, higher Ka is identified. Next step, we are enlisting the equation as follows. Enlist the equation as follows. First one is initial concentration. Write the initial concentration. Okay. Then write the change in concentration. Then we are writing the equilibrium concentration. Okay. We discussed earlier, like the same steps we are doing here. Now, Equilibrium concentration will be, for the reactant it will be C minus C alpha, and for products it will be C alpha, C alpha. Okay, so C alpha will be the concentration of H3O plus, and the acid, if depending upon the acid, the C alpha changes. Okay, next, substitute these values in Ka. Substitute in Ka and solve for alpha. Solve alpha. We will get a quadratic equation. Okay, then we are solving the quadratic equation, we will get the alpha value. Okay, next we are calculating the equilibrium concentrations. Calculate equilibrium concentrations. Equilibrium concentration, that is, these are the equilibrium concentrations. So C alpha will be the concentration of H3O plus. So after getting the H3O plus concentration, we are calculating pH. Calculate pH, that is, pH is equal to minus log H3O plus. Okay, so H3O plus concentration we know, calculate pH from there. Like this, we are calculating the different steps involved to calculate pH of an acid. Okay, so problem is, the ionization constant of HF is 3.2 into 10 raised to minus 4. Calculate degree of dissociation, that is alpha, Ka is given, of HF in its 0.02 molar solution. So C is also given. Now calculate the concentration of this species, that is H3O plus, F minus concentration and HF in the solution and its pH. So first step, identify the acid. Acid is HF, hydrofluoric acid. Now write the balanced equation, that is, equation is HF plus H2O gives H3O plus F minus. Okay, this is the balanced reaction. Now next we are writing the initial concentration. This is C. C is 0.02. Here 0, 0. Okay, next step is change in concentration. We are writing is minus 0.02 alpha. Here it is 0.02 alpha and 0.02 alpha, C alpha. Okay, now equilibrium concentration will be C minus C alpha. So 0.02 minus 0.02 alpha. Here the same 0.02 alpha, 0.02 alpha. Now next we want to get the alpha value. For that, take Ka. Ka is equilibrium constant is given, that is 3.2 into 10 raised to minus 4. So Ka will be equal to C square alpha square. So C got cancelled. So C is 0.02 alpha square. Okay, product square. By next denominator is 1 minus alpha. Okay, C got cancelled. So 1 minus alpha. Now this is equal to 3.2 into 10 raised to minus 4. Now we will get a quadratic equation based on alpha square. The quadratic equation will be alpha square 0.02 alpha square will be equal to 3.2 into 10 raised to minus 4 into 1 minus alpha. Okay, so we are dividing the whole equation by 0.02. Now we will get the equation like this. Alpha square, okay, plus 1.6 into 10 raised to minus 2 alpha. Okay, minus 2 alpha minus 3.2 into 10 raised to 3.2 becomes 1.6. Okay, so 1.6 into 10 raised to minus 2 will be equal to 0. So alpha square term, alpha term and a constant term. The equation will be like this. From this we are solving the equation and we will get the alpha. Alpha is equal to plus or minus 0.12. Okay, 0.12 will be the answer. So minus value we are neglecting. So the answer is 0.12. So alpha is 0.12. Okay, next we have to find the concentration of these species. Okay, then after that we are calculating pH. Okay, so H3O plus concentration equal F minus concentration. Okay, both are same. This is equal to C alpha, that is 0.02 into 0.12. Answer is 2.4 into 10 raised to minus 3 molar. Okay, now next we have to calculate the concentration of HF. HF is C minus C alpha into alpha is 0.12. Okay, answer is 17.6 into 10 raised to minus 3 molar. So, we got all the concentration species. Okay, products and the reactants and products concentration we got, equilibrium concentrations we already calculated. Next, at last we are calculating pH. pH is equal to minus log H3O plus concentration. H3O plus concentration is, we got H3O plus concentration, that is minus log 2.4 into 10 raised to minus 3. Okay. Here, the last answer is equal to calculating minus of log 2.4 plus 3 log 10. At last, we will get the value 2.62. Okay. So, we got the pH. Like this, we can calculate the value of pH using Ka and alpha. Okay. Now, similar method can be used in the case of weak bases. Okay. So, ionization of weak acid we already discussed. Next, weak bases. So, let the base be MOH. The equation will be like this. This is equal to equilibrium. Reaction will be like this, M plus OH minus. This is the base. Okay. And instead of, in the case of ionization of weak acid, the ionization constant or equilibrium constant is Ka. Here it will be Kb. Okay. So, Kb will be equal to the concentration of products by concentration of reactant. This will be the case. Okay. Similar reaction. Alpha is the degree of dissociation or extent of ionization. Degree of dissociation. Okay. Now, this will be equal to C alpha the whole square by C minus C alpha is equal to C alpha square by C into 1 minus alpha. C got cancelled. So, C alpha square by 1 minus alpha. Okay. So, similar method we are using. Let us take an example in the case of ammonia. Ammonia is a base. Okay. Ammonia. Ammonia on ionization with water gives NH4 plus. This is the acid plus OH minus. Okay. This will be the reaction. Now, instead of pKa here we are writing pKb. This is equal to minus log Kb. So, the same method can be used to calculate pKb. Okay. This is in the case of weak bases. Okay.